Hi, I'm Tyler Maschino, and I'm a current graduate student here at the Department of Electrical and Computer Engineering at Miami University. I received my undergraduate degree from Miami University as well in electrical engineering, and I decided to pursue electrical engineering as a result of my involvement in an AP Physics class in high school. In that class, during the last few weeks, we had the opportunity to experiment with breadboards and wiring diagrams to really make something with a circuit, and that was my first exposure to anything electronic other than consumer electronics. So it was really a mesmerizing experience and broadened my worldview to encompass a whole new discipline. And so when I came to Miami University, it only made sense that I look into electrical engineering as my degree program. I decided to continue with studies in electrical and computer engineering my junior year when I took a class taught by Dr. Garmatuk in the Department of Electrical and Computer Engineering, and it was an electromagnetics class. And in that class we learned about a system of wireless power transfer that allowed essentially wireless power transfer over multiple feet without any wires whatsoever. And it was relatively safe because it used magnetic resonance rather than electric fields to convey that power. And we learned about the work that MIT had done and then what Miami University had followed up with the senior design project. And the entire discipline was very fascinating to me. So when junior year came around and it was time to start applying for jobs or looking at graduate school and kind of planning the career path, I decided to look into the graduate program at Miami and to continue with the 4+1 degree and make my research work revolve around wireless power transfer. That one of the biggest things that hadn't been addressed was power theft. And as we move to a world without wires and there's ubiquitous power everywhere, in the sense that every device you own, every consumer electronic can be powered remotely without having any sort of cables, we realized that that could be a problem when it comes time to have essentially devices that are in the public area. So if you go to a doctor's office and, is it ethical for you to get power from that doctor's office to power your cell phone? Where's the line essentially when it comes to power theft? And so as we looked into that further, we found that all of the systems of wireless power transfer currently run on one frequency generally, and that frequency varies, but all these systems only have one frequency that they run on. And when they're running on this one frequency, that means that anyone with a device that could listen could essentially tap into that one frequency and leach power from that grid. So we looked into making a system that allowed you to jump between a series of frequencies so that way you could vary that frequency over time, and someone who is sniffing that network to find out what that frequency is wouldn't necessarily be able to do that because there'd be an extra layer of protection, and that would be that frequency shifting. In this wireless power transfer system that I designed, I have my own printed circuit boards here that I had fabricated by a company on the West Coast, and each of these printed circuit boards has a specific function. You'll see here that we have a screen that adjusts the password, and depending on what I set from 1 to 32, that'll be the password of the transmitter. And once I press the push button, it locks in that password and it starts sequencing between each of the different states for the wireless power transfer system. And each state corresponds to a different frequency. When we turn on power, we're presented with the same option as on the transmitter side. We have a screen here that has a number from 1 through 32, and that indicates the password. And when we've selected the password and pressed the push button to lock in that password, the receiver will sit in this state 1 and wait until it sees power transfer coming from the transmitter being in state 1 as well. And as soon as that happens, it will begin cycling through each of the different states and corresponding to the different frequencies. So once the system is in sync, the oscilloscope will begin to show a waveform here that signifies that the wireless power transfer has been received by the receiver. And if the system were not in sync, that signal would just look primarily like noise. This is because the transmitter and receiver don't have the same password, so they aren't receiving any voltage on the receiver. This project was a truly great experience where I was able to use all of the circuit skills that I learned throughout my time here at Miami University to really develop a full project and proof of concept with something that had not really been done before. And that was really cool to be able to both contribute something to the field as well as really fine-tune all of those skills that I've been working to craft over these last 4 or 5 years.